Welcome students, welcome to the lecture series on polarization. This is the part of your module optics. So in this class we are going to discuss about polarizer, analyzer and then Malass's law. So let us start with polarizer. So actually a polarizer is an optical filter that lets light waves of a specific polarization pass through it while blocking light waves of other polarization. It means a polarizer will only pass a specific plane of vibration or specific polarization through it. Other polarization, it just stops them. Okay, so only a single plane of vibration or single polarization state can pass through a polarizer. Others cannot. Then what is analyzer? Analyzer is used to check the state of polarization of the light wave or to check whether your incident wave is polarized or not. So your analyzer can check the state of polarization of the incident wave, or it can check your incident wave is polarized or not. So let us see how it works. So it is your unpolarized light, and you know we can resolve our unpolarized light into mutually perpendicular components. So we have taken this like this, one is parallel to this plane and one is perpendicular to this plane. So it is your unpolarized light. So it is hitting a polarizer. So the vibration which is parallel to the axis of the polarizer will only pass through, and the other which is perpendicular to this board is actually perpendicular to this axis also. So it will not pass through, it will just stop. So here it will be a intensity loss. Okay, so in your unpolarized light, the component which is parallel to the axis can only pass through it, pass through the polarizer. So after crossing the polarizer, you are having a polarized light because it contains only a single plane of vibration or single state of polarization. So your polarizer actually polarizes this light. Then you put an analyzer to check your polarizer had worked or not. Okay, so in your analyzer, in the first case, the axis of the analyzer is parallel to the polarizer. So then also your plane of vibration is parallel to the axis of analyzer. So it will pass through it. There will be no loss of intensity because all the vibrations are parallel to it. So all the vibration will pass through. Here the perpendicular components are present, so it will not pass through. So there will be intensity loss. But here there is no perpendicular component is present because all are cut through this polarizer. So it will pass through the analyzer also. But if you put your analyzer at 90 degree with comparison of the polarizer, then this vibration is also at 90 degree with analyzer. So it will not pass through. So there will be an intensity loss. Okay. So if you place your polarizer and analyzer parallel, then the whole intensity passes through. But if you place your polarizer and analyzer at 90 degree, then it will not pass through. It will pass through the polarizer, but it will not pass through the analyzer because here it is at 90 degree. So you can actually think this polarizer is actually a slit kind of thing. You can think there is a slit or hole kind of thing. So only the vibrations which are parallel to this slit are passing through. Others, it doesn't allow them to pass through. As you think there is a slit kind of thing, so only the vibrations which are parallel to it are passing through, others are not. Okay. So as I am telling that here is a intensity loss. So this is a question to you. Can you tell me what will be the intensity loss here? Here is the unpolarized light. Say the intensity is I0. So what will be the intensity loss? So what will be the intensity here after crossing the polarizer? You can think yourself and answer. What will be the intensity after crossing a polarizer? What will be the intensity of the unpolarized light? Now our nickel prism can be used as polarizer and analyzer both. So let us see. So here see you have placed two nickel like this. So this is your polarizer, this is your analyzer. This is your polarizer nickel, this is your analyzer nickel. So you see the plane of vibrations which are parallel to this board are passing through, and the perpendiculars are total internal reflection is here. Then there is a lamp blank plane, so it is absorbed here. So only one plane of vibration is passing through. So your first polarizer means your first nickel is actually polarizing the light. So it is acting as polarizer. Then you place another nickel here. So it is your analyzer. So as the axes are parallel, your light is just passing through. There is no loss of intensity. Here is loss of intensity. Again, if you put your nickel at 90 degree with comparison the first one, means your analyzer, there will be no intensity passing through, as I have discussed. So see, your nickel prism is as well as you can as good as to use as polarizer and analyzer both. So this first case is known as parallel nickel because the axis of polarizer and analyzer are parallel. Thus it is called parallel nickels. Here the axis of polarizer and analyzer are at 90 degree. Thus it is called cross nickels. So it is parallel nickels, it is cross nickels. Then what is Malus's law? So Malus's law tells that the intensity of plane polarized light transmitted through an analyzer is proportional to the square of cosine of the angle between the plane of the polarizer and that of the analyzer. So let's see, this is your transmit plane of polarizer and this is your plane of analyzer. So there is an angle of theta. So the component of this wave which is parallel to this polarizer will pass through after polarizer. Then the component of this wave along the plane of analyzer will be E0 cos theta. E0 be the intensity after crossing the polarizer. It is important. E0 is the intensity after crossing the polarizer. It is not the incident intensity on the polarizer. So E0 is the intensity after crossing the polarizer. So this component is E0 cos theta. So the intensity after crossing the analyzer is actually I equal to I0 cos square theta. You know that intensity is square of amplitude. So we take the square. So intensity I equal to I0 cos square theta. I0 is actually E0 square. You can see here, this is your unpolarized light. This is your polarizer. So the waves which are parallel to this axis of polarizer are passing through. So you will have this wave only. Then you put your analyzer at an angle theta with comparison of this polarizer. So only the vibration or component of this wave which is parallel to this axis of analyzer are passing through. So the after crossing the analyzer, the intensity of this wave is I0 cos square theta. So what you have to remember, that this E0 is the intensity after crossing the polarizer and this theta is actually the angle between the polarizer and the analyzer. So what we have learned today about polarizer, about analyzer and Malus's law. Thank you.